So you see the title of my presentation, Postbiotic Metabolites, the New Frontier in Microbiome Science. In this graphic, I'm showing that the probiotic bacteria are supplied with the prebiotic food supply, but the ultimate end result is the production of these postbiotic metabolites. So I need to define postbiotic metabolites. They're the health-regulating compounds produced by probiotic bacteria, and more specifically, they're the compound produced by the bacteria and by their metabolism when they're digesting the foods that you give them. The bacteria digest and ferment the foods and produce these compounds that we call postbiotic metabolites. So I asked the question, why are probiotic bacteria important? And the answer is, probiotic bacteria are important because of the work they do. And the work that they do is that they digest the fibers in the foods that you supply them with and produce this wide range of compounds that we're calling postbiotic metabolites. And these compounds are the master health regulatory compounds for the entire body. They influence every single organ system, especially the immune system and the brain. And in this book, The Mind-Gut Connection, written by Emran Mayer, who's a very highly respected researcher in the microbiome industry, he tells us in his book that your bacteria use the information stored in their millions of genes to produce hundreds of thousands of metabolites. So this is truly the beginning of an entire new chapter in microbiome science. Spending less time focusing on identifying and naming strains of bacteria and shifting the focus over to what are the compounds that these bacteria produce? What are the health regulating aspects of these compounds that the bacteria produce, and which strains of bacteria are more efficient and more effective at producing these health regulating compounds? So this is an analogy that I've created to explain and emphasize the importance of these postbiotic metabolites. And so again, I'm asking, why are postbiotic metabolites important? And my analogy on the left here, actually we don't have this depiction, there we go. So this is a picture of Mission Control Center at NASA, which is where the space flights are controlled. And so in Mission Control Center, there are dozens of engineers and scientists, but there are hundreds of computers, and it's really the computers that regulate and control the space flights, making millions of decisions every second. In my analogy with the microbiome, the probiotic bacteria are like the scientists in mission control. They're important, but it's the thousands and thousands of these postbiotic metabolites that are really the master control compounds that are regulating everything related to health. For gastrointestinal problems, we have to consider more than just the bacteria. We have to consider the whole microbiome ecosystem. And in this particular study, it's telling us that the Lactobacillus acidophilus bacteria are involved in the process of protecting the colon from colon cancer. When you have dysbiosis, there's an elevated pH, and it allows the pathological bacteria to transform bile acids into metabolites that are capable of causing colon cancer. But the Lactobacillus acidophilus bacteria create a more acidic environment by creating short-chain fatty acids. They're acidic, so they lower the pH, which reduces the ability of the pathogens to convert bile acids to secondary metabolites. So it's not so much the bacteria, but it's the postbiotic metabolites that the bacteria create that reduce colon cancer risk. This slide, I'm letting you all know that the pharmaceutical industry also recognizes the importance of postbiotic metabolites. The pharmaceutical industry knows that this is an opportunity for them to develop new drugs that will be safer. They'll come to market faster, that'll allow the pharmaceutical industry to have to put less money into research and development, and a higher probability that the drugs are going to be successful because they're basing drugs on things that are naturally occurring in the human body. So I need to emphasize that greater microbiome diversity equals better health. So we need to ask the question, how do we teach our patients to get greater microbiome diversity? Well, they need to learn to consume a larger diversity of fiber-rich foods, because at the fiber-rich foods, the fibers are the primary food for your probiotic bacteria. So consuming a wider range and a greater diversity of fiber-rich foods allows you to grow a larger diversity of probiotic bacteria, which then produce a larger diversity of postbiotic metabolites, and you have better health. So here's a study that shows that women who have a greater microbiome diversity during pregnancy have healthier babies. There are fewer preterm births. And in this study, at old age, it's showing us that a greater diversity in mammals equates to greater longevity. So from birth to death, greater longevity equals better health. So the number one health goal is to achieve a greater diversity of probiotic metabolites. There are two ways to do this. Number one is to teach people how to ingest a greater diversity of fiber-rich foods. And the second way is to directly ingest postbiotic metabolites. So I call the fiber gap the number one nutritional deficiency in America. I think Russians probably eat better than Americans. And when I call the fiber gap, and I call fiber the number one nutritional deficiency, a lot of people argue with me and say, fiber's not a nutrient. But fiber is the number one nutrient for your 100 trillion guests that are living in your gastrointestinal tract. So we really need to re-emphasize how important a fiber-rich diet is. Constipation, the most common intestinal complaint in America, and 90% of Americans do not eat the recommended amount of daily fiber in their diets. Well, this is a YouTube video that I made. It's 8 minutes long, and you can watch my video if you just Google, my pointer here, Google Ross Pelton and salad buzz, B-U-Z-Z. What I'm teaching people here is how to save a lot of time making salads. And my theory is that people don't eat salads frequently enough because they're time consuming. It takes a lot of time to make a salad every day. But my process, I process all of my vegetables in one day, about 30 minutes. And the secret, after I'm done, squeeze a lemon and put the lemon juice on all the vegetables. The vitamin C in the lemon will preserve your vegetables in a container in your refrigerator for 1 week. So every night when I make our nighttime salad, I grab some lettuce, I grab some of the vegetables, I put some wild-caught salmon or some kind of protein on. It takes me 1 or 2 minutes to make my meal. And this is all the different types of vegetables I have. My lettuce mix, there's 4 different types of lettuce and all these different vegetables. So I've got 16 different types of fiber foods in my nighttime salad. Microbiome diversity. Now, before I leave this slide, I want to emphasize one other thing. Yes, it's important to take probiotics, but you must learn to feed your probiotic bacteria well. If you don't feed them well, they will not thrive and survive. In America, when I see somebody that's eating McDonald's or fast food, junk food, if they purchase a probiotic, it's a waste of money because they're not eating a fiber-rich diet, so they're not going to let their probiotics thrive and survive. So you have to learn how to feed your probiotic bacteria well. But this is showing a multi-year probiotic fermentation production process. On the right-hand image, it's showing the large fermentation vats that are used in this process. And in this process, we start out with 12 strains of bacteria, and then we put dozens of different types of organically grown foods, and there's mushrooms and seaweeds and fruits and vegetables. And then the bacteria are allowed to grow and digest and ferment these foods in the fermentation vats for 3 to 5 years before we encapsulate the final product. This is really a probiotic method using the probiotic bacteria to produce postbiotic metabolites. And I want to emphasize that this system over here with these fermentation vats, they really mimic the human digestive system. Here you have bacteria, you put in food, the bacteria produce the postbiotic metabolites. The same thing is happening in this commercial process. We're allowing the bacteria 3 to 5 years to digest the food to produce a multitude of postbiotic metabolites. So, this product is called Dr.OHHIRA's probiotics, and we now know that there are over 400 different postbiotic metabolites in the final product. So this is really not primarily probiotic. This is a fermented food that produces postbiotic metabolites, or primarily contains and delivers postbiotic metabolites. And this is a list of all the postbiotic metabolites that have been documented to be in Dr.OHHIRA's probiotics. And here is a list of some of the major classes of postbiotic metabolites that have been discovered so far. Your probiotic bacteria are magnificent little chemical manufacturing plants. And they produce all of your B vitamins and folic acid and the aromatic amino acids and the short-chain fatty acids. And as Emran Mayer tells us in his book, ultimately we will find hundreds of thousands of these compounds. So metabolomics is developing very rapidly, and this is a new field of science that's being developed specifically to study small molecular metabolites. Basically, this whole industry is developing because scientists are starting to understand how important these postbiotic metabolites are. The whole industry is developing to start to identify what these compounds are so we can learn more about the health regulating effects of these compounds. And so, again, this is developing very rapidly so that scientists can identify the small metabolites that are produced specifically and most probably by the probiotic bacteria in your microbiome. So one way to look at postbiotic metabolites is that they are an entire language, a method of communication, communicating with every single organ in your body, and again I emphasize, especially your immune system and your brain. So when people have dysbiosis, gastrointestinal distress, I emphasize all of these symptoms: gas, bloating, constipation, diarrhea, inflammation, pain. It's more than just bad bacteria. These people have things like inflammation and intestinal permeability and allergies and so forth, and leaky gut. And so you need to address the whole microbiome ecosystem, and that's what these postbiotic metabolites do. So when you deliver directly postbiotic metabolites, you will help somebody go from a highly inflamed gastrointestinal tract to a normal intestinal tract much quicker, because you're not just delivering bacteria in a capsule, you're directly delivering the postbiotic metabolites that have anti-inflammatory activity, they rebalance the acid-base level, they accelerate the regrowth of healthy new cells in the lining of the GI tract, they reinstitute the communication between the GI tract and the brain, the gut-brain communication. So it's a much faster, more efficient process of healing gastrointestinal problems when you can directly deliver the postbiotic metabolites. So here I'm just emphasizing that when you give Dr.OHHIRA's probiotics that directly delivers 400 postbiotic metabolites, you immediately start to transform the gastrointestinal tract. But when you just give probiotic bacteria, the bacteria first have to survive transit through the harsh acid environment in the stomach, and then they must find their fiber-rich foods when they reach the small intestine, and then they're entering a hostile environment with a lot of bad bacteria, and it's a highly inflamed environment, and It can be anywhere from 10 to 100 times to alkalins. So if the probiotic bacteria survive the acid, and if they can find the food they need, then they have to start the process of breaking down the food, incorporating that into their system, and start to produce the postbiotic metabolites. But if you can take a product that's delivering 400 postbiotic metabolites directly, you get rapid microbiome restoration. So postbiotic metabolites are the key regulators of health for every system in the body, and they are the new frontier in microbiome science.